is everybody today? I'm a little surprised people showed up. Um, Saturday, I figured it's going to be an empty room. I'll just go home. And routing with Linux is kind of a niche thing. It's not a real popular thing. So I was a little concerned. But here we are, routing with Linux, home to enterprise. Why am I presenting this? Like I said, routing with Linux is not commonly done. And I find that a little bit odd because everything else in Linux, the Swiss Army knife of operating systems, you say, well, I have a problem to solve. Can Linux do this? It can. Great. I'm going to do it. I need an NFS server. I'll do that with Linux. I need a nice SCSI target. I'll do that with Linux. I need a web server. I'll do that with Linux. I need a Samba server. I'll do that with Linux. I need an Active Directory. I can do that with Linux. I need routing. Should I do that with Linux? Everybody goes, no. And it's not always the best solution, but sometimes it is. And it's often a very good solution. And I think more people need to at least be aware of the fact that it can be done, how to do it, what it offers, and of course, where it's not necessarily the best. So what will this cover? This is not a how-to. This is not a how do I enable routing. This is routing with Linux correct for me? Does that disappoint anybody? Was anybody in here looking for hands-on? No? Good. So, tell me about you guys. Number one, how many of you provide services to your company? How many of you provide services to other companies? All right. Now, the people who provide service to your company may find this useful, you may not. People who provide services to other companies, because you run into many varying situations, are probably a little more likely to run into cases where you say, hey, you know what? I can do that, and I can do that well. And the reason I say people who provide service to their own company may not, it's like the gentleman and I were discussing earlier. A lot of times you get in a company, things are done the way they've always been done, and that's just how you do it. And I also think that's one of the larger reasons why Linux is not more commonly used. A lot of system guys are not networking guys. Most networking guys are not systems guys. You go to the networking department and you say, hey, I need to route 10 gigabits. I need 4 million packets a second. Well, they got their start getting Cisco certification. Got the next Cisco certification so that they could get a little higher, get a little better job, get another certification. The next thing you know, they say, great, we've got our Cisco rep on the phone. I just need a couple $100,000. So, I'm going to tell you about me. I got my start a little early. That's me getting started on the computer room. How many people recognize the system? 4, okay. So if you guys used computers in those days, you did not get a computer, start it up, put your program on, and use it. You wanted stuff to work. You learned about it, you hacked it, you made it work. I remember the first printer I got was an Oki Data. You didn't pop in a disk and install printer drivers. You got a book this thick with control codes, and you went into whatever word processing program you happened to have purchased, and you configured all those control codes. So I'm kind of used to doing things myself. That gives you a little bit of background on why I like to do things myself. So we're going to get into some features of routing. TLAs, FLAs, everybody knows what a TLA is? Good. Okay, DNS, DHCP, all varieties of NAT, access lists, RIP, OSPF, BGP, subinterfaces, VLANs, lag bonding, SNMP monitoring, NetFlow, VPNs, firewalls, load balancing, quality of service, traffic shaping, queuing, out-of-band management. In summary, virtually everything that commercial routers can do, and more. I've tried pretty hard to find things that you can get from a Cisco or a Juniper or a Brocade that you cannot do with Linux. And there are a couple, but there are very few. On the flip side, if you try to do things on Cisco, there are a lot of things you cannot do on a Cisco, a Juniper, or a Brocade that you can do with Linux. And we're going to get into a few of those. But we're going to look at some examples first. Who does not use a DWRT router at home? Anybody? A couple. DWRT, you already know, is a Linux distribution for commercial routers. it's universally a better option than what the companies have developed. To the point where a lot of companies don't even bother developing their own firmwares anymore. They just build hardware that's compatible with DDWRT and say, there you go. Okay, dedicated distributions, Bifrost, IPCOP, Smoothwall, Viata, ViOS, others. There are many BSD based. Everybody's heard of these? Has anybody used them? You mind telling me what you use them for? Okay? I mean, are you using these for, what's your attraction to that over other solutions? Okay, any other reasons? That's a totally valid reason. Mm-hmm. Right? You want to do round robin out those links. And you can also assign weights to those links so that if one is a little slower, it only gets used if the others are saturated. Fair enough. Does anybody here hold a Cisco certification? No? Okay. I was going to ask, how do you do that on a Cisco? And the answer is, it's possible. But, again, you're going to turn around, you're going to hand over your checkbook, close your eyes, and they're going to take what they want along the way. So, MikroTik, everybody heard of MikroTik? They make hardware boards that run Linux as the underlying OS. They have their GUI, which abstracts all the internals of Linux for people who are not strong Linux admins. And they're fairly small, they're fairly reasonable priced, they're good performance. One of the high draws to MikroTik is you can actually get service contracts. And you can call in and say, hey, I don't know what I'm doing, or this broke, or I'm confused. They'll hold your hand, walk through it. Another is the Ubiquiti Edge Max. Has anybody heard of these, used these? You have? We're going to get to there in about 2 sections from now. Zen, Barracuda, F5, other load balancers. Has anybody heard of these? Yeah. Now, they're called load balancers. They're routing. They are. They may be doing direct routing, they may be doing NAT, but they're routing. F5 doesn't even make an attempt to conceal the fact that they're running on top of CentOS. It's all Linux. And why are they doing that? Because it works, and it works well. Full discrete. There are cases where you want to dedicate a full discrete server to routing. It's not as common, but it does happen. So, why should you go? Freedom. This is the open source conference. Open source is about freedom, isn't it? It's the freedom to say, I don't like what this is doing, I want to change it. To say, I want to look at the source, I want to see how this is doing, I want to make improvements. I want to be able to control things. So what kind of freedoms do we get? Pardon me. Make full use of hardware without per resource licensing. Has anybody here ever had to pay a per user license fee? Per seat license fee? Per socket license fee? Yeah. We actually have a commercial product that I won't mention the name of. It's based on Linux, runs Linux, and it is only designed to support up to a certain amount of traffic. What we found is the only reason it can only support that amount of traffic is because they only put 512 megs of RAM in it. Once the warranty was void, we were no longer under the service contract. No limits to the company gives in there. Suddenly the thing can handle literally 10 times the traffic it could before. Just like that. But going through that company, if I wanted something to handle 10 times the traffic, I had to stick another 0 on the end of the price tag. Okay. Quite possibly. Patch and support updates without onerous support licenses. I take it there's not a lot of Cisco guys in here. If you have a Cisco device and you want an update to your iOS because it's 5 years old, what do you do? hopefully you've had a service contract, a SmartNet contract on that device for those 5 years. If you have been paying for the privilege of support for those 5 years, you can get an update. If you have not, too bad. I recently paid over $500 a piece for some nice Cisco access points because they are very high performance. When I got them, they had ancient versions of iOS on them where a lot of the features just didn't work. I called up, I said, listen guys, I don't have a SmartNet on these, but they're brand new. The version on here is old, and it sucks. Just as a one-time deal, can you guys give me the latest firmware for it? No. Sorry. Won't do it. Buy your contract. Okay, no vendor lock-in on software protocols or hardware. You buy a Cisco. Let's say you want a VPN. What VPN options do you have? You have IPsec and some vendor proprietary stuff. Can you do OpenVPN? No. Could they put OpenVPN in? Yes, they could. If they did, you would no longer be tied into their proprietary protocols. Big vendors like to lock you into those things. No surprise, right? Is anybody shocked by that? Okay, freedom from Big Brother. If you look at the list, the catalog of devices that are claimed to be backdoored by the NSA, you will find every large networking vendor. Dell, Juniper, Cisco, Brocade, Huawei. And that's even assuming that, Chinese companies like Huawei don't have state-sponsored backdoors. With Linux, you have at least some further assurance that you are not backdoored. It is not guaranteed. But for example, you can take CentOS, if that's what you're running. You can recompile packages against the source, which have presumably been inspected. You can check some files. You can make sure, okay, what I see in this source, that I don't find any evidence of backdooring in, that's actually what's running. My opinion is this. The NSA has vastly greater resources for intrusion than most people suspect. 8 years ago, people were claiming that the NSA were doing things that were considered so advanced that most of the world, including a lot of the IT world, said, your tinfoil hat's screwed on a little too tight. That's just silly, it's ridiculous, it's impossible. Well, we've since found out they were doing it the whole time. And they were doing it quite easily. We've found that, for example, they have been proven, it's shown that they've come out, they purposely weakened RSA and other encryption technologies to make it easier for them to decrypt. How long ago was it that you said, I've got RSA with 2 kilobit encryption. Who in the world is going to crack that? That wasn't too many years ago. And these days, not a deal for the NSA. They purposely put those things in there. They want in, they're in. We know that the NSA goes to companies such as cell phone providers, orders them to provide backdoors, orders them to provide communications logs, and orders them not to talk about it. If the leaked documents can be believed, they do have backdoors, again, in all the networking here. So, I think it's pretty safe to assume that if you're running any commercial product, one way or another, they can get in. Now, if you're running Linux, can they get in? Very well, maybe able to. They employ a very large number of very intelligent people who get paid a lot of money and nothing but figure out how to break into systems of all types. But, again, you at least have the assurance, however small it may be, that your particular version of Linux does not have a purpose-built backdoor for the NSA. They'll at least have to work for it. Does that answer the question? Okay. Virtualization. Not a big thing yet in IT, is it? Come on, chuckle. Um, Virtualization reduces hardware footprints, reduces power, can reduce cabling, switch ports, and physical traffic. There are a lot of situations where people need routing between their VMs. They need natural routing, they need natural firewall. The traditional sense, well, you pass that out your 10 gig trunks to your switch, you pass that up to your core routers, hits the router, does all the processing, comes back down the same 10 gig switch port, back into your VM. Well, in some cases that's how it's going to be. In a lot of cases, I see people who are able to use the router right there in the virtual host, do the routing internally. They never get the physical switch ports. They're never getting those expensive links. They're never overloading their expensive core routers. Does that make sense in any case? Not necessarily, but there are a lot of cases where it does. And where it does, it can save you, again, hardware footprint, hardware costs, power, cabling, switch ports, and physical traffic. Cost effectiveness. Hardware. Again, like I said earlier, you go to your network and you say, I need to route 5 gigs and 5 million packets a second. They say, okay, well, what's your budget? You better have 6 figures. Well, fair enough. But the hardware to do that on with a Linux machine is in the 4-figure. Anybody here who's priced out any Cisco gear, any Juniper gear, any Brocade gear, it's expensive. Software, again, updates, I don't want to keep a support contract year after year after year on my routers just so that I can get updates. Manageability. Has anybody in here ever managed a Linux machine before? You guys already know how to manage Linux machines. And I believe you could learn how to manage Cisco gear, Juniper gear, Brocade gear. You're smart guys, you're capable. However, you already have a very large knowledge base, a lot of experience managing Linux gear. And there's no reason why, pardon me, my drink's getting too much, why you can't leverage those existing skills to manage your router as well. You can learn basic Cisco configuration management pretty quickly. If something goes wrong, wow, you're in deep waters. And you've got two options. You can spend a lot of time learning it. Or again, you've been spending a lot of money every year on these support contracts, and we call Cisco America. Linux machine goes wrong. Who here has a reasonable suspicion they could take care of it quickly by themselves? Okay, performance. I actually participated in an online discussion about a week ago about Linux routing. And one of the guys went off saying, well, this Juniper has a multi-terabit switch fabric. It's hardware ASICs. You're never going to be able to route stuff in software that would be able to do on this hardware. Went off on a long tirade. And my response to him was, you know what? You're right. Commodity hardware, general purpose CPUs, software routing can only go so far. So the mitigation of that is, Linux as a router is really only applicable when you need to route, say, less than 20 to 40 gigabits per second. Which was my way of being a little bit of a smart aleck. In the immediate response I got back, no way could Linux route 10 gigabits per second. No way. This is a $100 Ubiquiti EdgeMax router running Linux. It has a little ARM CPU in it. It will only route 3 gigabits per second because it only has 3 gigabit switch ports. Or links, I should say, Ethernet interfaces. And it will still do 1 million packets per second. And this costs $100. Does anybody want to see this? I'll pass it around. actually have used Linux for routing have shown that routing 10 gigabits works pretty well on modern hardware. Now, 4 or 5 years ago, they did a test where they said, we're going to see how much we can route. And to make sure the CPUs are not a bottleneck, we're actually going to use GPUs for the route tables. And what they found is that even with the GPUs, they could only get about 20 gigabits per second. The limitation was not the GPUs, it was not the CPUs, it was not the NICs. It was the IC9 on the motherboard, the Intel controller. Everybody familiar with that? It used to be that you had your frontside bus or your CPU, which connected via an external link to your controller hub. That then provided PCI links, SATA links, that sort of thing. That was the model. These days, PCIe lanes come right out of the CPUs. You get a dual socket E5 Xeon, you've got up to 80 PCIe lanes coming out at 8 gigabits bidirectional each. Bandwidth is no longer an issue. So at this point, people tend to hit bottlenecks when they're getting in the 30 to 40 gigabit range. Now, by show of hands, would that cover most of your routing needs? Is there anybody that would not cover? Okay, fair enough. So performance, it's fast. Viata did a comparison a few years ago to a Cisco 7204 VXR for BGP routing. The IBM server that they ran Viata on cost them $8,000. The upgraded 7204 VXR cost $35,000. The Viata was able to hold a much larger routing table. It was able to process incoming BGP routes much faster. It was able to handle much more traffic. And it was able to do so at a much lower latency. So, there is a point, like I said, where dedicated hardware is the only thing that will handle it. But for most people's needs, even commodity hardware can provide it faster than what they expect. So, any questions so far? Sorry, what was that? No, I'm kidding. All right. So, why not route with Linux? There is a limited selection of line cards. You can get Ethernet, you can get InfiniBand, you can get the S1s, you can get the S3 interfaces. I'm sure you could get a token ring interface if you had the full bundle one. Again, a few weeks ago, I was speaking to a gentleman who wanted to do a Linux router, and he said the reason is their internal network is all InfiniBand. And he did not want to have to go through a bridge to Ethernet to get it out to a commercial network. And if you say, okay, I want to route over InfiniBand with a Cisco Juniper Brocade, wow, all of a sudden you're talking a lot of zeros. And he said that it also gave them some advantages with the IP over InfiniBand stack under VMware. I didn't catch all the technical details, but that is the selection of line cards that you get. If you need anything other than that, it may not work for you. Mitigation, use Ethernet. Is anybody using any interfaces other than Ethernet right now? Nobody? No. Okay. Okay, there are fewer certified professionals, fewer certifications, and less depth of certifications. Which means when you go to hire someone, you can't say, show me the piece of paper that tells me that you read a book or a couple books, and then you pass the test, and then you've paid a bunch of money to Cisco and their affiliates. It also means you can't say, show me how in depth you have been certified to be. It also means you can't just put out an ad that says, you need CCIE and have 300 people show up at your door. Mitigation for that is empower yourself. Like I said, you guys know Linux. You guys know how to administer Linux. You're probably used to figuring out how to do things with Linux. You've probably looked at a few how-tos. You've probably used Google quite a bit. You've probably read books. And that same sort of thing can help you solve these problems. less or no commercial SLA-backed support. This, in my opinion, is the biggest reason. There are a lot of companies who are willing to spend egregious amounts of money for the guarantee that they will have less than a certain amount of downtime. And there are a lot of administrators who are willing to spend egregious amounts of the company's money to push any responsibility for downtime and outages on someone else. I've personally spoken with a lot of admins who say, there's no way in the world I would want to be responsible for the hardware on the server. That's why I pay, $50,000 a month in all my support contracts to Dell. So if anything breaks, they can be out here within a few hours and they can take care of it for me. There are a lot of networking guys that say, you know what, I don't want to be responsible if, for example, the BGP table isn't being interpreted correctly, and I'll spend $50,000 a month to make sure somebody else takes care of it. If that describes your organization, mitigation is buy Cisco. Spend the money if that's what your organization requires. And I've worked in companies where that was the case. Okay, commodity hardware only skills so far. Again, the mitigation, limit yourself to 10 gig or less Ethernet links. Don't try to go from 40 gig Ethernet or 100 gig Ethernet. I assume nobody uses it. Could be wrong. Is anybody using 10 gig? Good. I have a couple of file servers that have dual 10 gigabit links in between. This is not necessarily routing, but doing round robin traffic modeling. With a single stream between them, I can get 17 gigabits without warming up the CPUs. 2 or more streams, solid 20 gigabits. The days, and a lot of people's mindset in terms of routing and networking and all with Linux comes from the old days when trying to do gigabit Ethernet would swamp your CPU with interrupts. And so they had to come up with things like interrupt coalescing. Those days are over. Those days are gone. We're not dealing with Pentium 233s anymore. So, if Linux routing is not for you, alternatives, use commercial gear. You can get used to Cisco stuff somewhat inexpensively on eBay. Again, good luck with OS updates. Good luck with support. As I'm sure you all know, there are places you can get those updates other than Cisco. But again, a lot of us like the idea that our router firmware does not have a backdoor in it, and we're somewhat sure. Layer 3 switches. Does anybody do routing on their switches? Okay. Layer 3 switches don't necessarily do true routing. They route the first packet, make an entry in the table, and simply switch after that. Makes them very fast. There are a lot of limitations, and depending on which features you need, they may simply not work for you. For example, if you need NAT, your switch isn't going to do it. If you need one-to-one NAT, source NAT, destination NAT, not going to happen. Firewall, it's also not going to happen. The other alternative, again, hand over your checkbook. Your vendor will take what they need. So what's a good use case? People with heavy Linux admin skills and networking. Experience, I should say, and networking. I think a lot of admins sell themselves short by not understanding more networking, just like a lot of networking people sell themselves short by not understanding systems. But it sounds like we have a pretty good group in here that does have a fairly good grasp of networking. Another good use case is the open source do-it-yourself mindset. I assume since this is the open source conference, there's at least some of that here. Strong networking skills and knowledge. If you do not feel comfortable in your networking skills, you probably shouldn't be running a router anymore. Fair enough? Questions and answers. Does anybody have a question? Nobody? Go ahead. Typically when you're talking about the number of rules, you're talking access lists or firewalls. Strict routing, is generally pretty efficient because you get a packet, you match it against your routing table, which often internally is done with a hash to speed it up, and you take whatever answer you get from there and you send it out. Does anybody here use dynamic routing protocols, BGP, OSPF? Okay. A lot of the overhead comes, for example, with BGP. Let's say that you're one of these poor schmucks that's getting a full BGP table, and you're getting several million routes announced to you over that link. And you gotta remember, these are routes from all over the internet. Routes come up, routes come down. You may be getting hundreds or thousands or tens of thousands of changes to that per second. And your machine has to sit there and update the routing table based on these incoming changes. Total now, let's say you buy a Cisco 2621 and you connect to your providers, and you've got your AS number, and you say, give me a BGP feed. What happens with that 2621? Because getting a full BGP feed takes a lot of RAM. In the case of IATA versus the 7204 VXR, I think 16,000 of the cost of that VXR is simply upgrading to the maximum amount of RAM. And again, vendor lock-in, Cisco RAM, Cisco flash memory. Anybody ever priced it out? No. It's a joke. It is ridiculously expensive. And it's normal RAM. It's normal flash. You can go to crucial.com and get memory for it at, a quarter or a tenth of the price. You ever need support on it, Cisco's going to say, sorry, we know you've been paying thousands of bucks a year in your support contract, but no. So, sorry, I'm digressing a bit. Performance. The other aspect of BGP is, do you have enough CPU in order to process all these incoming changes? The first area where the IATA box was able to beat the first reason they were able to beat the Cisco was simply because it had more RAM. But the second is, general purpose CPUs are extremely fast these days. The commodity of scale has made modern processors incredibly powerful. We take it for granted a lot. The little box that I passed around that has a little 1 gigahertz ARM core, that's a 5-level CPU. If we're talking E3 and E5 Xeon, it's worlds better. You can do a lot of BGP processing with that. And Cisco's because, a lot of times they are not keeping up and using general purpose CPUs, do not have that much processing power. They also, in my opinion, don't put it in simply because they want you to buy a bigger box. They're interested in selling expensive things. Now, firewalling and access lists, which is originally what you asked about. Yes, the number of rules that you have can determine your overall performance. That's true in any firewall situation. And there's a lot of science and a lot of art that goes into ordering your firewall rules so that the least number have to be traversed. For example, what's your most common traffic? What do most of your packets look like? Let's get the rules that affect that right near the top so you can hit and accept and not have to go through the other 300,000. But there's another feature of Linux that I didn't put in the chart that I happen to love, and it's called IPsense. Has anybody ever heard of IPsense? I'm actually surprised. Very few people have it. Say, IPset's missing. What's that? It is a hashing mechanism to hash your rules. And there are many different kinds of lists you can hash. You can hash addresses. You can hash addresses and ports. You can hash source address, source port, destination port. Because it's a hash list, the lookup is extremely quick. So when you integrate these into your firewall in Linux, you no longer have to do a linear operation and say, let's go through every one of these rules. You can say, hey, match it against this hash. Is that a match? Out here. Or, is that a match against this hash or whitelist? Pass it. Now here's a performance example. Using 2 Linux routers and 2 Linux load balancers with firewall in between. This was 2 years ago. Our company came under this distributed denial of service attack. We have a forums area on our site. Someone was upset that they weren't allowed to do whatever they wanted on the forums. We hired out to distribute denial of service attack. Between the two routers and the two load balancers, we were able to do piece scrubbing, firewalling, packet inspection, and for the little bit that came through, I was processing almost in real time offending IP addresses, pumping these into an IP set, and we were able to keep all services behind these routers and load balancers completely usable without taxing the servers at all. Can you say that for a Cisco or a Juniper? No, you can't. They don't have the performance, they don't have the features. So the traditional answer is, okay, you contract with someone else to handle all this incoming traffic. They do all the scrubbing, they do all the filtering, they do all the firewalling, and they pass the legitimate stuff on to you. Guess what they're using to do that with? Linux. You know, this is not some arcane magic that Linux can't do or the commodity hardware can't do. They're doing it. There's another feature, deep packet inspection. There's a module that you can use to actually inspect the contents of the packets as they come in. Has anybody here heard of Heartbleed? Heartbeat, or I should say, made use of which feature of SSL? Heartbeat. One of the things you can do with the deep packet inspection, you can look in there for the signatures of an SSL heartbeat packet, and you can say, drop this packet. Don't accept SSL heartbeat packets. It's not the best answer, it's not a long-term answer, it's not a permanent answer, but hey, all of a sudden, guess what? Whether your vendors have released patches or not, that compromise is no longer going to work against any of the systems on your network. That's a pretty spiffy thing. Does that answer your question? Okay. And actually, let me say one more thing. Firewalling, or when I talk about routing and the vast power of, say, a multi-terabit Juniper fabric, that's just routing. Firewalling does not work like that. Firewalling is pretty much entirely a CPU-dependent action. It is process switches, systems. So, the capacity of firewall really comes down to how fast is your CPU. Now, you can go out and buy a firewall that has a fairly big CPU. If you spend a lot of money, and again, you're paying a lot of money for licensing fees, updates, or you know what, you can spend a few $1,000 on a dual E5 Xeon that, frankly, your network's going to crap out or keel over before that firewall is, unless you're doing something horrendously off. Now, here's an example of using IPsense. We have my day job is an e-commerce shop, and there are certain sections of the world where, for every one legitimate order that we get 10 to 20 fraudulent orders. You can probably guess some of those sections. Now, these fraudulent orders cost us money. We're losing money on processing it. We're losing money on the credit card transaction. We're losing money on the credit card refund. We have also seen snake eater attacks. Tell me if anybody's ever heard of this one. A person in China built a site to directly proxy ours. It was all custom written to, again, proxy ours, intercept all of our links, put in their domain information so they can present themselves exactly as if they were us. So that as the checkout went through, they could take the credit card. Anybody ever seen that? You have? It's not uncommon. And the more we looked into it, the more we found out that whenever they investigate these things, it always gets to a certain point and ends because it seems to be state-sponsored. So, at this point, we decided we're not going to allow traffic from Asia. We don't get any legitimate orders. We're losing money. Okay. How do we block traffic from Asia? Okay, you can go out and you can get all the ranges for AppNet. Oh wait, we do want to support New Zealand and Australia. Okay, let's do those ranges. So let's go into our firewall and let's say, how do we allow all the networks from AppNet? There are a lot of big networks, a lot of small networks. How do we then allow all the networks from Australia and New Zealand? The list, as I recall, there are, I want to say there's, between the two lists we maintain, there are 3,000 different networks. If I put those all in a traditional firewall access list-based rule set, boy, I don't care what device you're using. It's not going to work well. Because we're using IPsets, and these are all hashed, we can pass a gigabit through there without even taxing the machines. It's just not a big deal. So, any other questions? No? Alright, any complaints? Alrighty, where did my router end up? If I don't get that back, my kids can't watch Netflix. Home family use. Do you have any special needs? I'm a big fan of these edge routers. They have very low latency, very high processing power. They do use a Viata OS on them, which means you do need to learn the Viata interface. Maybe it probably may not. But other than that, for most broadband things, if you're not doing anything special, any of the DDWRT routers are fine. Now, if you were to say, okay, I've got a 100 megabit link, and I want to run an OpenVPN connection from that router somewhere else, and speed through it, then you start getting into the things like how fast is the CPU in there, how fast can I do that VPN encryption. But for just general home use, DDWRT routers are usually enough. One caveat, doing wireless encryption can be enough CPU use that a lot of the less expensive ones are then bottlenecked and do not route as well. If you're buying something like the new Asus, I don't know the acronym, Dark Knights that have a really powerful CPU in there, it's not an issue. If you have a cheap little Action Tech that came from CenturyLink, that may be the case, and you may want to separate your wireless router or access point from your wired router. That's often the case simply because either you have a big enough house or your house is built with dense enough of materials that your wireless doesn't work very well all over. Throw in a wired router and then run multiple access points around the house where you need them. Any other questions? Probably the best design distribution for doing that would be IPsense. BSD has a strong history in networking, and I don't know if this is still the case. At least as of 5 or 6 years ago, BSD is still beating Linux in terms of networking. That's their strong point. Things may have changed. However, like I said, there are quite a few distributions. I just picked the most common ones between Bifrost, IPCOM, Superwall, BIOS. It'd be pretty easy. Go ahead. I'm actually ignorant of that. So it'd be pretty easy to look through these distributions, see which support it. That being said, unless you're unhappy with IPsense, I don't see any reason to ditch it. Yeah. And again, all that is basically done on the routing team. I have some examples where people have used Linux without a distribution to do round robin out ADSL lines. It's not difficult, but there is the factor of Do you want the GUI to do it for you, or do you want to learn the nuts and bolts mechanics? Both are valid, but make a distribution choice based on which you prefer. Anybody else? For the most part, you can do that with just buying 2 access points. If you give them the same SSID, the same encryption, the same credentials, devices are usually pretty good about just picking which one has the strongest signal and flipping over to its use. I actually had a guy come to me this week and he said, I've got these 2 access points and I always have to walk far enough away that I completely drop from one before it'll connect to the other. Turned out he had different user credentials, different SSIDs, which your device is going to treat as 2 different networks. But part of the 802.11 standard is multiple SSIDs with same credentials are considered the same network. The device is able to, or is supposed to be able to, pick between the strongest signal. Nope. That's all handled on the 802.11 side. You can do either, but you want 2 different channels. And you know how wireless channels work? Whatever channel you pick, you're using that channel and you're using 2 channels on either side of it. There's a lot of bleed over. So you want to maintain a lot of segregation. That being said, a lot of the routers these days have an auto channel selection, and a lot of them are really good. They can gather statistics over time and do better analysis than you can with a spot check with yours analyzing. Yep, and it'll sit there and watch. And it's watching long term, not just once in a while. One caveat to roaming between access points. Every device I've ever seen will simply go based on signal strength. It will not change depending on data throughput or whether data is actually getting through or not. So if you have an access point at each end of your house and somebody pulls the wire on the access point closest to you, your device usually will not switch to the other one. You're sitting going, I'm not getting any connection. What's going on? Yeah, you've got a good link to the router. The router just can't talk, or the access point just can't talk out. Set it up like that, and unless you've got pretty poor equipment, it'll work. That's how I do it at my house. I have one on the upstairs floor, one on the downstairs floor, and never had to actually disassociate. It just works wherever I go. That's how we have it set up in the office. It's a pretty standard setup. I really haven't followed a lot of that hardware. I know the Asus Dark Knights are phenomenal, but I think they're about $150. They can be dissimilar. Yep. Yep. And you've only got a few users on this, right? Yeah. Does everybody know what happens as you try to put a lot of users on an access point? It gives up the ghost real quick. Not just because there's a lot of contention, but just because there's a lot of back and forth and time sharing that needs to happen to make all this work. This is not a $30,000 cell antenna; it's a $100 radio. It depends on the access point itself. It can be dependent on the radio, and it can be dependent on the CPU. If you're at 10 or under, you generally don't have to worry. If you're talking 20 to 30, you've got to worry. And if you're talking more than 20 or 30, you really need to be splitting that up or buying some really high-end hardware. The $500 Cisco access points that I mentioned, they're only G access points. But you could put 50 or 60 people on them, and they still perform respectably well. 2 years ago at the VMworld conference, in one demonstration, we had sessions over a single access point, and it was slow. It was bad, but it worked. You try doing that over an old $20 Linksys WRT54G, it's not going to happen. Not at all. Any other questions? All right, we're 5 minutes early. Thank you very much. I appreciate it all.